Oh, hi, everyone. I'm Yan. Welcome back to class. Today, we will continue our exploration of machine learning. We will discuss our first machine learning algorithm, k-nearest neighbors, which is easy to understand and very effective. Okay, before we get started, we will revisit some concept we covered in the previous class. So can anyone remind us what supervised learning is? Okay, good job. Yes, please also remember that supervised learning can be categorized into two main types: regression, which predicts continuous numerical values, and a classification, which predicts categorical labels. Okay, here's what we will cover today. I will start by introducing the dataset we'll work with. So next, I will cover the concept k-nearest neighbors, and then we will build it by pure Python from scratch. So any questions here? Okay, good. Let's run through a quick example classifying movies into romance or action movies. Let's say someone watched a lot of movies and counted the number of kicks and kisses in each movie. I have plotted 6 movies by the number of the kisses and the kicks in each movie in this figure. Now you find a movie you haven't seen yet and want to know if it's a romance movie or an action movie. But we don't know its type, but we can find out how many kicks and kisses it has. We just plotted it as a large question mark along with other movies in this figure too. So this is the value table. So this is how we visualize these dots. And for example, like a California Man, this movie has 3 kicks and 104 kisses. So its type is romance. And the bottom one is the movie question mark. We don't know its type. It shows unknown here. But what we know is it has 18 kicks, 90 cases. So we need to find a way figure that out. We will use the KNN. This is how KNN works. Step 1, prepare the training data set. We need to have an existing set of data, and we also need to know the labels for all of them. Step 2, when we are giving a new piece of data without a label, we compare the new piece of data to the whole training data set, calculating the distance between the new pieces and the training data set. Step 3, select the k-nearest neighbors. We need to sort the training examples by distance, look at the top k closest ones. So this is where the k comes from. We call it KNN. So what does the k refers to? It comes from here. It means that we need to pick the top k closest neighbor. K is a small integer, usually less than 20. The last step is a majority vote. We take a majority vote from the k nearest neighbors, and the majority will be the new class we assign to the data we were asked to classify. Any question about this part? Okay, let's just circle back to our movie data set. We want to use the KNN, right? We need to follow those steps. So step 1, prepare the training data set. This is what we already have. We have a data set with like 6 movies in it. So the next step is compute distances. So this is what I already did. I already compute the distance between this training data set and the movie question mark. And I list all these values here. So don't worry about how I did these calculations right now. We will get into that in a few minutes. Like step 3, select the k nearest neighbors. Now that we have all this distance to our unknown movie, we need to find the k nearest neighbor, the movies, by sorting the distances in decreasing order. This is what I already did. Let's assume k equals 3. So the 3 closest movies will be California Man. He's not really into dudes, the beautiful woman. So we already know that the type of these 3 movies is romance, right? So after voting, this movie question mark is also a romance movie. Okay, I have a question here. What if we assign the value k to be 5? What type will the question mark movie will be? Okay, think about that. Good. Yeah, by setting k equals 5, the KNN will consider those 5 nearest neighbors, right? So the top 3 are romance. These 2 are action. So after voting, so the type is still romance. You're right. Good job. Okay, any questions here? Okay, let's continue. We already know what our data set is, how KNN works. Let's see what this would look like in actual code. And along the way, I will continue introducing the Python tools, machine learning terminology. Okay, let's just switch to our Python environment. Oh, can you see my screen? This is the Python environment I'm currently I'm using WSL, and I use VS Code to connect to the WSL system. But it doesn't matter what your environment is. You can use Jupyter Lab or Linux. Both are fine as long as you can run your Python code. So first, we will create a Python module called KNN, where we will place all the code used in this class. You can create your own file and enter the code when we progress, or you could just download this file directly from Canvas. But I suggest the best way to learn is to start with a black module and enter code by yourself. So first, let's create this KN file. We will create a few support functions before we create the full KN algorithm. So in this code, I like 2 modules. The first one is NumPy. I think you should all know it. This is the scientific computing package. The second module is operator. We will use it later. So don't worry now. I have a question for you here. Do you still remember how KNN works? What is the first step of KNN algorithm? Yes, right. Good job. The first step is preparing the training data set. So this function here, create data set, is for this first step. This creates the data set and the labels. We just use our movie data set. Do you still remember those numbers? This is the number of kicks. This is the number of kicks. And we have 6 movies in our training data set. For labels, I use the letters. R refers to romance. A refers to action. Great, great. I will give you like about like 2 minutes. You can type in all this code, or if you have any question about this part, you can ask me or discuss with your classmates. Okay? All right. So please remember, we need to save the code before we use it. Okay? And next, we need to go to the folder where the kn file is. I'm already here. This is my folder, and we can see the kn file is here. Now, we need to launch the Python command line. Then we need to load this Python module we just created. We need to type in import KNN. Okay, follow me? So in these functions, just as I said, they create groups and labels and return them as variables. So we need to do a quick test. KNN dot create data set. Let's just inspect these two variables. We can type its name. Okay, it works. So let's check this. Let's check this variable labels. Okay, so you can see all these numbers, and we have like 6 movies in the data set. Do you have any question here? We have an idea of how to create or load data in Python, right? And we also have an idea of how the KNN algorithm works. So let's put it together and do some classification. So next step, we will build a function to run the KNN algorithm on one piece of data, the movie question mark. I will first show the function in pseudocode. So let's go back to our PowerPoint. Yeah. Okay, just let's continue. Here we will build a function to run the KNN algorithm on testing dataset. I just first show you the function in pseudocode, and then I will show you the actual Python code, and explain what everything the code does. Remember, the goal of this function is to use the KNN, right? We need to follow the steps we just learned about this algorithm. We finished the first step, preparing the dataset. So who can remind us what the next step is? What is the step 2? Yeah, calculating the distance. We need to calculate the distance between the testing dataset and the training dataset, right? So here, how do we do that? We use the Euclidean distance. It is widely used in machine learning. So I'll show you what it is. This is the formula of the Euclidean distance. I won't cover this in our class because I believe you already learned it from your math class, but we will do a quick practice here. Is that okay? The distance between points 0 and 0 and 1, 2, this is 2.00 and 1, 2. How should we calculate their Euclidean distance? Oh, yes. I'm glad you still know how to do the calculations. Great. But what if we are working with the 4 features? So like this distance between points 1001 and 7694. So now it's points with four numbers. It's like a vector. It's not only has like x, y, but it's like vector. It has four features. Any volunteers? Okay, perfect. Still the same way. Okay, let's just circle back. So we finished the step two. What is the step three? Yes, select k nearest neighbors. We need to take k items with the lowest distance. And the final step, what is the final step? Majority vote. Yes, find the majority class among these k items and return this majority class as our prediction for the testing data set. It's perfect. So now we're ready. Okay, I just show you what the pseudocode is for these classification functions. So let's take a look at what the real code of this classify function is. I already defined these functions in KNN module. It's called classify zero function. And this function takes four inputs. The first one in X, it is our testing data, right? The second one, data set, it is our training data set. Labels. It is the labels of this training data set. So K refers to the number of nearest neighbors we're going to use. So let's continue. We need to implement step 2, 3, 4 of the KN algorithm. So step 2 is calculate the distance. Here, this is how we do the calculations by using the Euclidean distance. Following this calculation, we need to sort distance. Don't forget that. Some students always, missing this part. And the next, this part, we will do the majority voting by using these k items. The first k or lowest k distance are used to vote on the class of in X. The input k should always be a positive integer. So the lastly, we need to take the class count dictionary and sort it to get the largest number, to get the highest vote, and return it as the labels of our testing data set. So this is what the classification function looks like. Do you have any questions about this part? Okay, so let's try to predict the question mark together. Is that okay? But we need to save this function before we use it. Don't forget that. KNN dot classify zero. The movie of the question mark, I still remember it has like 18 kicks, 90 cases. Testing data set, we just use this one group. We just created them. Labels. Three. What's the prediction of this question mark movie? It's R, romance. Maybe we can change this value to say, what if a movie has a lot of kicks and less kisses? Oh yeah, it's an action movie, right? Okay, congratulations. We just made our first classifier. Oh, now let's have a discussion time. Feel free to take some time to write and test your own KNN algorithm. or ask me any question you might have or discuss with your classmates. But here I also have one more questions for you. What is pros and cons of KNN algorithm? Okay. Okay, any thoughts, any ideas? Oh, you all made good points. Let's make a summary. Yeah, the advantage of KNN, as you all see that KNN is simple, right? Straightforward, easy to implement, and easy to use, easy to understand. So, so, so that's why it is the first algorithm just we learn together. And the second one is there's no training phase, right? So, which means that new data can be added to our training data set directly without retraining this model. So for the real world project, if your training data set needs to be updated like regularly, and you don't want to retrain your model, so maybe you can consider use the KN algorithm because we don't need to train the model. But there's also some disadvantages, right? First one is the cost of the computation. It could be very, very high if we have a very large training data, especially like real world project. It might has a huge training data set. And for KNN, we know that for each testing data set, we need to compare it with all the elements in the training data set. So it could be very expensive. I mean, like time, memory. So for the real world project, you need to consider this cost and decide if it's a good choice or not. And the last one is the choice of K. It could be very sensitive because the different value of K can lead to this different performance of this model. And we will do a real world project later. Then you can try to use the different value of K. Then you will see that this performance could be not could be like not very stable actually. So when we make the when we select the value of the key, we must be very careful and need to do some tests. Okay. So any question here? You all did a good job. So thank you.